Hello everyone and welcome back to the series of Digital Logic Design, and today we will study about the sequential circuits. In our everyday life, all the handheld devices like cell phone, navigation receivers, personal computer, cameras or media player and all the virtual electronic consumer product have ability to receive, send, store, retrieve and process information represented in the binary format. The technology enabling and supporting these devices is critically dependent on electronic component that can store information, which means that all these devices have a memory. The digital circuits so far we have studied are combinational, which means that their output depends only on the immediate input and they have no memory. And now we will study about the sequential circuit which uses memory. In the given figure we have a block diagram of a sequential circuit which consists of a combinational circuit to which storage elements are connected to form a feedback path. The storage elements are the devices which can store a binary information, like it can be a 1 or a 0. The binary information stored in this element at any given time defines the state of the sequential circuit. The sequential circuit receives binary information from external inputs and together with the present state of the storage element determine the binary value of the output. Or we can say that the output of a sequential circuit is dependent on the external input and the previous output of the circuit which was stored in the memory element. The external inputs used in the sequential circuit also determine the condition for changing the state in the storage element. And the block diagram also demonstrates that output in the sequential circuit are a function not only of input but also of the present state of the storage element. Or we can say that the next state of the storage element is also a function of external input and the present state, because the value stored in the memory element is the output of the sequential circuit. Thus, a sequential circuit is specified by a time sequence of input, output, and internal states of the system, where in contrast, the output of the combinational logic circuit depends only on the present value of the input. The sequential circuits are broadly divided into two types, and this is dependent on how they change their values. The first one is known as synchronous sequential circuit and the later one is asynchronous sequential circuit. A synchronous sequential circuit is a system whose behavior can be defined from the knowledge of its signal at discrete instant of time. This means that in this type of systems, we deploy a special type of device which produces a synchronization signal, because all the elements in this system are synchronized. This means that the computational activity will occur at the same time among the elements, where the behavior of an asynchronous sequential circuit depends upon the input signal at any instant of time and the order in which input change. In this type of system, there is a no common signal which synchronize the various elements, and the change in the value of one element is dependent on the other one. Now we will study about asynchronous sequential circuits. The storage element commonly used in asynchronous sequential circuit are the time delay devices. The storage capability of a time delay device varies with time it takes for the signal to propagate through the device. In practice, the propagation delay of a logic gate is sufficient duration to produce the required delay. So the actual delay unit may not be necessary because the same delay is caused through the elements present in the system. In gate type asynchronous system, the storage element consists of logic gates whose propagation delay provides the required storage. Thus, a asynchronous sequential circuit may be regarded as a combinational circuit with feedback, where no as such memory element are directly present. Now, in contrast to asynchronous sequential circuit, the synchronous sequential circuit employs signal that affect the storage element only at a discrete instant of time. This synchronization among various elements is achieved by a timing device known as a clock generator. This clock generator produces a clock signal having a form of periodic train of clock pulses. In circuits, the clock signal is commonly denoted by an identifier clock or CLK, and the clock pulses are distributed throughout the system in such a way that the storage elements are affected only with the arrival of each pulse. Within the synchronous sequential circuit, these clock pulses determine when the computational activity will occur within the circuit, and the other signals such as external input determine what changes will take place affecting the storage element and the output. This means that if you apply or change the level of external input, it calculates what value is going to be stored or what will be the new output. But the change in the value of synchronous sequential circuit is dependent on the clock signal. Like if we have a circuit that adds and stores two binary numbers, as the inputs are applied, the circuit would calculate their sum, but this circuit will store the values only at the occurrence of a clock pulse. The synchronous sequential circuit that uses clock pulse to control the storage element are known as clock sequential circuit and are the type most frequently encountered in practice.
Thanks for watching the video and stay connected for more interesting videos.